Hello and welcome to my channel. In this video, I'll be covering Lab 1 population growth. So in this lab, we want to enter the starting population size for the llamas in a barn, I guess. And then we also want to add in the and population size of the llamas. And then we want our program to figure out how many years is required for the population to increase from the starting size to the ending size. Alright, and every year 1/3 of the llamas population are going to be born and 1/4 of the llamas population is going to pass away. Alright, and so let's get started. Let me make directory population, cd population. I just press tab after pop. That's a shortcut to complete your sentences. Alright, and then let me download the required files and ls to check I have the C. I could have just checked it this way as well, but since they mentioned ls here. So implementation details, luckily for us they have created the pseudo code for us, and yeah, let's get started. So we want the user to enter the starting size, the ending size, and let's create variables for that. Alright, so integer start size, and then we want an integer to represent the end size. Yeah, so as per the implementation details, they are saying that if a user enters a number that is less than 9, then we should reprompt the user. And in the lecture, David Mellon mentioned that the best way to write a code like that is to use a do while, such that if the number entered by the user does not conform to the conditions that is set by the do while loop, we want to reprompt the user. Alright, so do, then we have a while. Alright, and then here we want to prompt the user for the start size. So get int start size equals to get int start size. Alright, and as long as the start size is less than 9, we want the user to enter again. Alright, now for the end size. For the end size, we want this number to be more or equals to the starting size. So as long as the user enters a number less than the starting size, we want to reprompt the user. And for that too, we want to use a do while loop. Alright, so and size is equals to get int and size. Alright, and for that too, we want, as you can see, I forgot my semicolons. Too used to writing JavaScript code now. And size, as long as the end size is less than the start size, we want to reprompt the user. Okay, so now we have that. The third section in the pseudocode is to calculate the number of years until we reach the threshold. And for that, we have to use a while loop, which will loop through the population. So every single year, the current population will increase, and we will track the number of years that has passed so that we know how many years it will take to reach the end size. And for that, we want to create another variable, which is current population. And this current population, after we have received the start size and the end size, we want to set the current population to be the start size. Alright, and then as the loop is looping, the current population is going to increase as the number of years go by. And for the number of years, we want another function, so number of years. Okay, so the loop is gonna be as long as the current population is less than the n size, then we want to run this loop. Okay, so how is the loop gonna work? Every single year, 1/3 of new llamas are born and 1/4 of llamas pass away. So for that, we can do current population is gonna be equals to current population plus current population. Sorry. Wow, that's a long word. Maybe I can use current pop instead. Current pop, current pop, current pop. And here as well, current pop. Okay. So current population divided by 3 minus current pop divide by 4. So this is the number of llamas that are born, this is the number of llamas that pass away, and this is the original llama count. Okay, so like David Mellon would say, there is something wrong with the design and the style of this code. I could actually cut down the amount of code in this line with a trick, which is using plus equals. Alright, so what this would do is whatever the current population is, it will add this to the current population. Alright, so this is what happens when 1 year goes by. Alright, so that's why we can add the number of years by 1. Okay, so after one loop, it's gonna be added by 1. Alright, so yeah, as long as the current population, I change this to pop instead. As long as the current population is less than the n size, we want this loop to run. And as soon as the current population is more than or equals to the n size, then we know that we have reached the goal of this program. So hopefully this works. Okay, before that, the last step is to print the number of years, which is gonna be printf years, then %s, sorry, %i, number of years. Alright, so let's hope this works. Make population. Okay, so some errors. Current population, yeah. Make population. Yes. Okay. Hopefully that's the end of. Oh yeah, there's another one. Number of. Oh, okay, yeah. So number of years. I incremented it here, but we never initialized it to any values yet. So we want it to be 0 in the beginning. Okay. So make population done. Let's do /population. Start size 100, end size 200, and we end up with 9 years. Alright, let me just add \n just for better visuals. /population 100, 200, and there we go. And yeah, that's that. Let's try with 1,200, 1,300, 1 year. Okay, nice. Let me just check 50, and we passed all the checks. If you guys benefited from this video, hit the like button and smash the subscribe button. And if you have any questions with regards to this problem, this lab, or other problem sets, just comment down below and I'll try my best to help you guys out. And see you guys on the next video. Bye bye.